Good day, ladies and gentlemen. My name is Honorable Maji Solomon. I am an inventor of an offhand method of teaching in Western education. Right now, I am going to explain the various organs in the alimentary canal of a man. The various organs in the digestive system of a man. I have drawn the diagram in the first place. At this point in time, I am going to explain them one after the other. I'm going to explain the various organs one after the other. Here we have, as you can see, we have alimentary canal of a man, otherwise known as digestive system of a man. Here we have teeth, we have mouth. Alimentary canal of a man starts from the mouth and ends at the anus. It starts from the mouth. The alimentary canal of a man starts from the mouth here and ends at the anus. Here we have salivary gland. Salivary gland. Okay. We have salivary gland. We have salivary gland. When a man takes in food, the food will be properly chewed using the teeth. The food will be properly chewed using the teeth. And then the food will roll into bolus using the tongue. Look at the tongue. It will roll into bolus. The food will roll into bolus used with the aid of tongue. And it moves downwards through a peristaltic movement. The food will move downwards to the stomach. For information, digestion of starch starts from the mouth. There is an organ called salivary gland. This salivary gland secretes saliva, and the saliva contains an enzyme called ptyalin. An enzyme called ptyalin. An enzyme called ptyalin. Okay? Ptyalin converts starch to maltose. It converts starch to maltose. Okay, when a man takes in food, the food will be properly chewed and it will roll into bolus with the aid of tongue. The food will roll into bolus, passes through the esophagus or gullet, down to where we have a stomach. In the stomach, the gastric gland in the stomach secretes what we call enzymes. Enzymes like pepsin, enzymes like renin. In the stomach, the gastric gland secretes enzymes like pepsin and renin. Pepsin converts protein to peptones. It converts protein to peptones. All right? Renin curdles milk. It is an enzyme that curdles milk. Renin acts on milk. Okay, in the same stomach, there is an acid called HCl, hydrochloric acid, being secreted by the gastric gland. The gastric gland in the stomach secretes an acid called hydrochloric acid. This HCl, hydrochloric acid, helps in killing the bacteria in the stomach. Okay? From there, the food will now move to the smaller part. Here, the food will be shown. That's what's called shown in the stomach. In the first place, in the stomach, the food will be shown by the muscular contraction. Muscular contraction of the stomach. The shunning movement of the food will now mix the food with the digestive juice. Here, the food will turn into a semi-liquid called chyme. Semi-liquid called chyme. 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 In the stomach, the food will be shown. And the food in the stomach will be converted to a semi-liquid called chyme. 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 Alright? After that, the food will now move downwards to where we have duodenum. In the duodenum, we have pancreas. Look at the pancreas. Look at the pancreas. Look at the pancreas. Look at the pancreas. Pancreas. In the duodenum, we have pancreas. Pancreas secretes pancreatic juice, which contains enzymes like amylase, lipase, and trypsin. Amylase is amylase. Amylase. In the duodenum, we have these three enzymes: amylase, lipase, and trypsin. Amylase, as you can see, amylase in the duodenum. Pancreas secretes pancreatic juice, which contains the three enzymes: amylase, lipase, and trypsin. Amylase converts starch to maltose. Lipase converts fats and oil to fatty acid and glycerol. Not glycerol. It is not called glycerol. It is called glycerol. IPA. International pronunciation of alphabet. Glycerol, not glycerol. Okay. Amylase converts starch to maltose. Lipase converts fats and oil to fatty acid and glycerol. Trypsin converts protein to peptones and polypeptides. All right? Okay. Here we have, in the same duodenum, we have a liver. Liver secretes bile. We have gallbladder here. Liver secretes bile. Look at the bile inside the gallbladder. Look at the bile inside the gallbladder. Look at the bile. Look at the bile. Okay? Okay. Now, we have a bile duct. This channel is called bile duct. And this is a liver. This organ you are seeing is a liver. Okay? And this liquid we are seeing is what we call bile. In the duodenum, the food has been converted into a liquid form called chyle. 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 In the duodenum here. The food has turned into chyle. Excuse me. Chyle. It's now in a liquid form. Okay. What next? The food is now in a liquid form. This excuse me. This bile, as you can see, it helps in emulsifying fats and oil. It helps in the emulsification of fats and oil. Okay. Here, the food has turned into a liquid form. It will now move downwards to where we have the small intestine. Just like I told you, small intestine comprises duodenum, jejunum, and ileum. Three of them are referred to as small intestine. All right? Now, in the small intestine here, there are enzymes. In the small intestine here, we call it small intestine, not small intestine. Small intestine. In the small intestine here, there are some enzymes that are being secreted by the intestinal wall, intestinal juice. In the small intestine, we have a intestinal wall, and the intestinal wall secretes intestinal juice, which contains some enzymes. Enzymes like maltase. We have maltase. We have lipase. In the small intestine, we have the following enzymes: maltase, lipase, erepsin. We have sucrase. We have lactase. In the small intestine, we have the following enzymes. And these enzymes they have their functions to perform. The first one, maltase. Maltase converts maltose to glucose. Okay? Lipase converts fats and oil. Fats and oils to fatty acid and glycerol. To fatty acid and glycerol. Eruption converts polypeptide to amino acid. Polypeptides to amino acid. Okay? Sucrase converts sucrose to glucose. Lactase converts lactose to glucose. And galactose. Okay. Here, these enzymes have done a great job. What next? The end product of protein is amino acid here in the small intestine. In the small intestine, two things are observable. We have absorption and digestion. Digestion and absorption. Okay. Now that these enzymes have done a great job, what next? The end product of protein is amino acid. The end product of starch is glucose. The end product of fats and oil is fatty acid and glycerol. All right? All these end products will move into the bloodstream. The end products after the digestion, the end products will move into the bloodstream through the finger-like structures known as villi. The end product after the digestion, after the breakdown of food, after the breakdown of large molecule of food, after the breaking down of large molecule of food, the end product of the food will now move into the bloodstream through the finger-like structure known as villi. Alright? The undigested food, the one that is not digested and the one that is not useful to the body, will now move from the small intestine here down to where we have a Sikkum. Look at Sikkum. Sikkum is part of the large intestine. Here we have appendix. Minor digestion of food takes place in the Sikkum. There are bacteria in the Sikkum that acts on cellulose. Here, vitamin B and K are synthesized in this place, in the Sikkum. Alright? There is a small bag called appendix. Appendix stores stony materials, hard materials like stones, seeds, bones. That is why if in the Western world, if a child is born, there is need to carry out surgical operation on that particular child so as to remove the appendix, because it's of no use. If this appendix, if the stony materials are full in this appendix, the person whose appendix is full will be having a pain in his or her stomach. And there's need for the appendix to be removed. A doctor will carry out a surgical operation so as to remove the appendix. The appendix will be cut off. Then there will be no more appendix any longer. Okay. Minor digestion, back to business. Minor digestion takes place in the Sikkum. Cellulose bacteria are there, synthesizing vitamin B and K. Okay. The undigested food will now move from the small intestine here down to large intestine. I said if it contains stones, bones, seeds, and the rest of them, they will fall into the small bag here called appendix. Those stony materials or hard materials will fall into the appendix. Okay. The remaining ones will go like this, down to where we have rectum. Rectum is a tube that stores feces. Rectum is a tube that stores feces before its final removal from the body through the anus. Look at the rectum. Rectum is also part of large intestine. Rectum, okay, look at the large intestines. We have Sikkum. We have a ascending column. It's a large intestine. We have a descending column. Look at ascending column. Look at it. It's a large intestine. Look at descending column. It's a large intestine. Look at rectum. Rectum. It's a large intestine. Okay? So, the undigested food will now move from the small intestine down to large intestine, and it passes through this ascending column, which is a large intestine also. It goes down to where we have descending column. From there to the rectum or rectum, before its final removal from the body through the anus. Before it moves from this region, the area where we have a sikkum, it has the undigested food has already absorbed water. Then it goes like this. It passes through the ascending column, passes like this, down to where we have descending column. Look at the descending column. From there it goes to where we have a rectum or rectum. Here it has turned to feces. It has turned to feces. Feces. It has turned feces. Feces or excreta. Feces. Before its final removal from the body through the anus. Okay, for your information, liver plays a vital role. Liver, as you can see, look at the liver, is an organ that plays a vital role. Liver is an organ that plays a vital role. It helps in storing the end products after the digestion. Liver stores glucose in form of glycogen. There is a hormone called insulin. Insulin will convert glucose into glycogen, and the liver will store it. Liver stores glucose in form of glycogen. It has to be converted into glycogen before the liver could store it. Okay? Liver also stores amino acid. If there is insufficient glucose in the body, in the bloodstream, to be precise, if there is insufficient glucose in the bloodstream, there is a hormone called glucagon. Glucagon will send a signal, to send a message to the liver, telling the liver that there is insufficient glucose in the bloodstream. Then, liver will release glycogen. And the same hormone, which is called glucagon, will convert glycogen into glucose before sending it into the bloodstream. So, liver plays a vital role in the digestive system of a man, in the digestive system of a human being. If there is excess of amino acid in the liver can convert it into glycogen. Liver can convert it into glucose. So liver plays a vital role in this respect. Thank you so much.